one of those tabs that start auto-playing. Interesting that AutoMod flagged that as a identity. Oh, okay, I can see that. Right. Yeah. Fair enough. Right. Who is all here today? I got a handful of people. It's time to get going. Aha. Yeah. It's a an older racial slur, so I'm sure that's why it flagged it. Unintentional, I completely assume, but yeah, that's what a 50s era one. All right. Well, let's get going with design patterns. So I got, I'll basically you'll be getting your midterm presentation grades here pretty soon. I got the other classes marked up during my office hours. Yours should be coming later this afternoon. I don't anticipate any problems. Yeah, POC isn't a term that would be blocked. That's weird. Anyway, yeah, so those should be coming up soon. I didn't finalize your homework assignment yet, so you get a free pass for the weekend at least. So we will have some design pattern stuff starting on Monday probably. And what else? Trying to think if there's anything else going on. Use the time to work on your term project stuff that you've got going on. Don't forget to upload your meeting minutes, all that fun weekly reminder type of stuff. What else did I want to talk about? Thought there was something else as important, but I guess not. Just enjoy the beautiful weekend after class is done, I suppose. So, what we're going to cover today is we're going to go over the model view controller pattern in a bit more detail. And I know I kind of talked about it briefly a few classes ago, but we're going to dig into it this time. We're also going to talk about the most valuable pattern, model view presenter, which is less exciting than most valuable pattern. But basically, these are two sides of a very similar design pattern in a way. So they're both separating out responsibilities. Here, we're going to really dig into MVC. MVP, I'm going to talk about more in relation to MVC. We're going to look at some sequence diagrams, something that we haven't checked out in quite a while. And I've got a nifty little demo for you as well. And the spoiler is that it is PHP based. So those of you who absolutely despise PHP, you're going to get some of that later today. Are they used together? No, you would use one or the other generally. but you can tack on some of your other design patterns on here. We'll kind of talk about how you can add on the observer to MVC, for instance. So it should be fun. So let's start with MVC. So we talked about this before, and if you don't remember, basically the entire purpose of MVC is to really split apart responsibilities in any kind of like a user forward type of application, something where you would have a user interface of some kind. And the reason why that's kind of important is the V is the view. That's where you're taking data and presenting it to the user. Or it doesn't have to be a user, it could be presenting it to an automated system or an API of some kind. So user is always a fluid term here, right? It's going to be some entity that needs to see data. It could even be as simple as presenting data to a web scraper if you want to go down that route. But this is an architectural pattern, meaning that it's kind of looking at it from the more static side. We're structuring our code, and basically we're breaking things apart. So on this slide, there is a lot of information about some terms that we haven't really talked about. So we've haven't talked about coupling too much. Next slide's also, one of the next slides is also going to talk about cohesion. I thought I had it right here. Anyway, one of the goals that you want to have with your projects, and this is from like a class diagram type of perspective, you want them to be very loosely coupled. And what that means is that you want your classes to basically be self-reliant and not have too many dependencies on other classes. Now you can have connections, obviously, right? I mean, you need to transfer data. You need to be able to call other APIs and so on and so forth. But you don't want to, say, have to make an update in one class and then immediately have to make a bunch of other changes elsewhere. Right? If you have to make one change, you want it to be localized to that class. That's kind of where MVC is getting us with this kind of pattern. So that's the term loosely coupled. You want projects to be as loosely coupled as possible within reason, right? You don't want to go like way overboard and get this fragmented mess. But with that, I'm going to talk about cohesion in a little bit as well. Cohesion is another one of these software engineering-y terms where it means effectively focus of your class. So if something is very singularly focused, right? I have a class, it does one job, and it does it very well. That would be highly cohesive. It is internal to itself. Whereas if you have one like God class, which does everything, we'll talk about those on Monday with anti-patterns, that would have a very low cohesion, right? It does too much. And why is that a problem? If I make one update, I'm going to have to make a slew of other updates inside there because there is just so much to deal with inside this class. Right? Like think of your first ever, major Java programs, for instance. You probably created a new project in Eclipse or IntelliJ or whatever your favorite Java development platform is, and you get your default Java class and you put everything inside of that. That's an example of something that's very non-cohesive. There's just too much happening. Ideally, you would split it apart. Every class would be separated out into its responsibility, and it would only do that, and then you would import it or you would extend it in some way. That's kind of where we're bringing in these object-oriented patterns, these principles here. So how does that fit in with MVC? MVC is all about splitting apart responsibilities. You have a model, you have a view, you have a controller. They all have particular jobs. There are some slight dependencies between each other, but changing, for instance, the front end has no impact on the database calls. Changing how you route users from one area of the application to another, right? Like they click a button and it changes the GUI, or you click a link and it goes to a different web page. That has no impact on the database. That has no impact on the actual views being presented other than you're calling it. So effectively, we are splitting things apart here. So there's some interesting topics in here. So coupling, we talked about, we want to decouple as much as possible. The data, the state of the application, basically this is the controller side where we're trying to figure out what the user wants to be seeing and doing. We don't care about the GUI. We don't care about the database. We just want to be able to load in modules appropriately. So again, everything should be relatively independent of each other in this particular model. So how do we implement this thing? It's one of these concepts where it makes a lot of sense, right? Let's split apart all of these pieces. But if you actually sit down to do it, there is a lot of overhead with it. So if you were a great example, and I'm going to keep coming back to this, are web applications because they're very easily expressed in Model View Controller. If you're doing a very simple website, like a very bare bones basic HTML, maybe some PHP code, very limited database on the back end, more often than not, when you start building that up, it's all going to be like one PHP script and it's all kind of interspersed. That would horribly violate Model View Controller because everything is in one page. Whereas if you want to add on MVC, your view is going to be the HTML front end. The model is going to be how you get data out of the database. And the controller is going to be how you move from one page to another. Or how the user talks to the model. There's some fine distinctions there. One of the examples that came up last class, I don't have it in the slides, but think about a data entry website. So you have a web page full of like text boxes and you're entering in data, right? So you're putting in, basically you're populating a database, for instance. You put in, on this first page, there's a bunch of text boxes, there's buttons, standard user interface, that's your view. The model, or sorry, the controller takes that data and calls the model. The model then is responsible for inserting it into the database. So we have a very nice separation of concerns here. And again, there is some overhead with this model, with this particular design pattern. Basically, you have a lot of extra effort up front. So think of it this way. You have basically different aspects of the system. And the next slide is going to be even a little bit more different of a view. Here, there is no direct link between the view and the controller. Right? There's a link between the user and the two of them. On this slide, there is a direct linkage. MVC has, you can implement it in different ways, basically, with who is related to who in this particular model. But the key here is that the user is going to visit your application, right? They're going to see whatever view is being presented. So the view is seen by the user. The user interacts with the view, which passes data to the controller. The controller will manipulate your model in some way. And manipulate could be get data, it could be insert data, update. Effectively, we're saying, model, we need some data, do something with it. And the model then is going to talk to the database, it's going to talk to your text file, your XML files, whatever your data set is, and it's going to pull it out. And you can even, in here, make some, do some manipulations of that data too. Right, let's say I'm pulling out 500 users out of a database table, and all I need is the count of how many of their birthdays are in 2020. That's something you could do in SQL by itself, right? Like you do that count SQL syntax. But if you wanted to do it code-wise in your model, that can be done as an internal model function. Again, you're massaging data and returning it to the view in this particular example here. So hopefully, if anybody's not following, please let me know. But basically, think of model, view, controller as completely separate entities. So some of the implementation points here, the model's going to be focusing on the data for that problem domain. And where I'm kind of starting to repeat myself is that the model does not care about the view. The model could care less about what your home page is, about if you're on the user profile page or the data entry page or update profile. or if it's a phone application even, could be different screens that you're showing, right? Main menu or gameplay or inventory. That's the view. We don't care from the model perspective. The model is only responsible for getting data and manipulating data and then transferring it. Likewise, the view doesn't care about the controller. The view doesn't care about the model. The view is just there to present information. The controller, then, you can almost think of it as like a middle point between these two. User, or the view talks to the controller, says, hey, I need this information. Controller talks to the model. Model retrieves that information and either sends it to the view or sends it to the controller, depends on your particular flavor of implementation. But we have a nice separation here. So, and this is another view of our system where, if you want basically some more detail, I've got a nicely pixelated set of states here, or different aspects of MVC with state changes, with view changes, user interactions. Basically, this kind of spells out what some of the different responsibilities are in MVC. But this is more if you want to go back and look at it. So in a bit more detail then, let's actually talk about these particular pieces and what they're supposed to be doing, and then we're going to go on to a sequence diagram here. Actually, you know what? I've already talked about these. If this isn't clear, please let me know. But again, we're separating out responsibilities is the key takeaway here. Model, data and state, view, render to the user, controller, act as a translation layer between the two. If that's not clear, please stop me. Otherwise, I'm going to pop over here to some of the little gotchas and caveats with MVC. Paused for effect. So, some key points about MVC and what makes it MVC over some of the other patterns. The model only knows about itself, right? So that's one key distinction. Generally, when you implement this and you, like, say, model it as a class diagram, or whatever model you have, artifact you have for this particular system, there is not really there's no direct instance of the view or the controller within the model, right? We only know about ourself, the model. We only have hooks for dealing with data. There's no reference to the view, no reference to the controller. We are our own entity. And why is this a good idea, right? Why don't we have a reference? That would make life a heck of a lot easier. Maybe I need to talk to the view. Consider that the entire point of separating our responsibilities here is that by being independent, like a strong independent class all by ourselves here, we can be reused in other parts of the project. So let's say that this is not a simple web application. Let's say it's a business-wide, enterprise resource management system, like an ERP type of thing, where we have employee data, we have product data, we have a whole bunch of different massive databases across our corporation, our made-up corporation. Our model, and if we're like representing this thing as a model view controller type of application, we could have a model hook into one component. It could hook into another component. It could hook into as many as we want. Basically, it's just going to act almost like an API for these various components that we have. So there's nothing wrong with saying, let's have 20 MVC projects and we have one common model between all of them, right? Because we only have one database. Or we could have multiple models. It just kind of depends on your situation. But by being independent, we don't have any direct linkage. Other people, other classes can call us and incorporate them in their system. That term that is what I'm describing here is reuse. Right? We can reuse our code in multiple places at very little detriment. Now, if the model has to update, you have to update all the other controllers, right? You have to know what data is coming in, what's going out, what the calls are. But that is something that you'd have to do anyway. So it's kind of a good thing. And by having no references to the viewer or the controller, it might actually be unaware that they even exist. It is just a shapeless entity with fully realized calls in or out. So could be a good thing, could be a bad thing, depends on your situation. I have seen MVC patterns where there are references, so it slightly violates these definitions, but it still works okay. So the other side of things. Let's say that we have a multiple, so you'd have multiple controllers and views with one model for, yeah, basically you could. So I'm going to show you a web application in a few moments here where it's CodeIgniter, so it's a nifty little PHP framework. I could have one model and I could have multiple CodeIgniter instances basically, and they would all call that model. Yeah. I mean, think of it this way. If you consider accessing data out of a database, you're going to have functions for like inserting data, retrieving data, updating data. There's no reason to duplicate that effort if you have a nice generalized interface, right? So there's nothing wrong with overlaying these patterns on each other, as long as you're separating out your sub-projects nicely, right? You don't want like one view referencing, multiple. You don't want too much overlap is kind of the point there. So reuse code within reason, I would say. Let me tell you the key reason why we do stuff like this for reuse and maintenance and ease of programming and all that. If you make one change in a particular component, and then you realize you have to make 500 changes elsewhere because that kind of trickled out, that's a lot of wasted time if you could have just put down a nice design pattern at the start. With that, pretend like you're working in a large company where you have 50 other developers all working on the same project. Each of you can be working on different modules where 10 of you work on views, a couple of you work on different controllers, some of you work on different models. You can all do this independently without breaking the development system, right? You have to know how avoiding the spaghetti, absolutely. Nice and clean and elegant interfaces to each other means that everybody can work on things at the same time without breaking things. Obviously, you have to know how to call each other's code, right? So we'd have published reference manuals for, okay, how do I insert data? How do I get data? That's a dependency, and we would need that. But we can abstract it out in such a way that it's nice and clean for everybody. So, kind of a nice pattern. One of the other cute things you can do with this is that you can actually treat the viewer, the controller, as an observer. So if you remember from last time, we talked about the observer pattern, where you have a subject being monitored, and if its state ever changes, it notifies all the attached observers. You could you could basically coerce MVC to do this, where if something changes in your model, you could update any observers. In this case, it could be like a view or a controller, just depends on how your application is set up. But let's say that the user needs, like, so I put an alarm clock in my phone system and it's an MVC pattern, right? 7 a.m. rolls along, alarm goes off. Let's say that my model is keeping an eye on the time. It sees the state has changed, alarm is now engaged, trigger the view that needs to set off the alarm. Might not be a great example. Think of, let's say that you're building a shopping cart, for instance, a web shopping cart, and I add a item to my shopping cart. So my internal state has changed. My model has been updated such that my cart object now has an item in there. Trigger the controller that says, look up similar items to what he put in his cart. Then that triggers a view that says, hey, you added this to your cart. Would you like this item, this item, and this item? And by the way, if you add another one, here's the 20% off code. This is all automatically triggered because in this instance, it's like an observer pattern. Still nicely separated because we're MVC, right? We can have a trigger basically watching the model, which then reflects elsewhere. So depending on the particulars of your system, you can overlay these patterns onto each other. Right? Think of how you might implement a visitor pattern here as well if you need different database search algorithms or something like that. There's lots of ways you could go with this, which is nice. All right, so other side of things here. The view and the controller have to know about the model. It's one of the things you can't get around. The view has to know what the model's going to be doing, and the controller has to know how to basically yank data out of it or to add data to it. So we have to know that. I've got sequence diagrams here to show you here what's going on. All right, advantages and disadvantages of this. Advantages I have pretty much already covered, right? So you have lots of reuse and maintenance capabilities with MVC. It's absolutely wonderful for separating out concerns. Lots of benefits with that, and I've already talked that to death, so I'm not going to really go through it again. Cohesion and coupling. Again, these are the newish terms that I've kind of introduced here. A very similar or singular focus on your responsibility is cohesion. You want that to be high. And very low coupling. We don't have too many connections that necessitate updates in multiple classes. So high cohesion, low coupling, that's your goal for OOP, basically. So nice things. We can also very easily add on new views to our programs. You need a new web page to render out or a new screen to render out. Just add in a new view, hook it into your controller. Life's good. You don't have to touch the model. There are disadvantages here, though. There can be a very steep learning curve with MVC, and that is not necessarily in the pattern. I mean, this is a pretty easy pattern, right? Separate all your responsibilities and you're good. The problem is with the frameworks that are out there. There is a lot of overhead, more or less, there is a lot of overhead with coding up some of these things, right? Because we're abstracting out so much, because we're separating out so much, you're going to have a lot of separate class files or a lot of like helper modules that kind of help you tease out this separated responsibility diagram here. So there's basically just a lot more moving pieces is kind of the issue here. And if you are looking at this as somebody new to MVC, you're going to think this learning curve is massive. Like it's really hard to figure out where I have to add code to simply render out a web page or load a new screen. It can be very detailed. But once you get it in place, things become very easy to do, right? It's kind of one of these problems with some of the design patterns where there is a lot of initial effort that has to go into it. But once you have that in place, you very quickly make back the time that you lost coding this thing up, right? And again, this was mostly useful for maybe not very complicated projects, but projects where you have a lot of moving pieces going on. Where you have multiple team members, where you have a larger web application to develop or a larger phone application, or even a PC application or something like that. There is overhead. I'm not going to, kind of hide that from you. But once you get it up and running, it's like glorious. I will say that. Okay, so sequence diagram. We haven't seen these in a while. This is a very, very simplistic view of getting some information out of an MVC framework. So here we have a web user. It's just a basic web app. Let's talk to a database, get some data. I need some information. So I send my request to the view. Well, what's the view? This would be a web page here, right? There will be buttons, fields to fill out, just the view. When you say overhead, I more so mean the overhead of installing a library or a framework, or could be setting it up yourself if you're doing like all the modeling and figuring out pieces. I will show you CodeIgniter and you will maybe see how much extra stuff there is. I guess let me give you a quick example because that's a really good question. How much overhead is there? I'm going to assume some of you have done web programming before. But if not, think of a like a PHP application, for instance. Basically, in HTML, when you're writing a website, you can add PHP code in there, which is executed on the server side. Depending on how lazy you want to be, you can intersperse PHP code with your HTML code. So like at the top, you could have all your database calls. Then you'd have all your nice formatting, like here's my header, here's my menu. Then the main body is going to be all dynamically generated from the database. And you'd put in calls to PHP there, get database row, loop through, and present my blog. Then you stop the PHP and there's your footer, web page is done. You can do all this in one file, happens very quickly. You have one thing to worry about, you're done. But that means that everything is in one place. Now, if you start adding on MVC, you add on all this overhead of extra files for, okay, what are the router functions? What are the view functions? What are the model functions? And pretty soon you have a whole bunch of like separate PHP files and folders, which are all very specific in what they're doing, but they're just kind of all over the place. So the overhead is all the extra framework in that way. You'll see here in a few moments. But just to kind of walk through the overall flow here. So I need information, so I talk to the view. The view realizes that I've asked for data. It's going to handle the event. This could be like clicking a button and then sending the data on. So I need information, button is clicked, tell the controller that the user clicked this button. The controller is like, well, oh crap, that's the query information button where I need data on this particular thing, right? Like maybe I'm looking up a profile or something like that. So the controller routes that query to the model. And all this basically is saying model.getInformation, right? The .getInformation function in here is a database lookup call. So select asterisk from users where ID equals something. So that's what the model's doing. It will then package it up nicely, maybe in like a JSON format or something easy to parse out, return it to the controller. Controller would check that, return it to the view. The view would then be updated with this new data. Right, so each of these actors here, so the view, the controller, the model, they're all responsible for themselves. They're receiving information on what they have to do, but the controller doesn't render any HTML. The controller doesn't execute any SQL. The model doesn't render any HTML. They're all responsible for themselves. And also here, let me point this out, by the way. If you're sending data from the internet, from a user to a backend, you better damn well verify it at this stage, not all the way down here. Don't validate your data after it's been inserted or checked and run against the database, because that's how you get SQL injection attacks happening. So do your validation way earlier. I was recently on a website, and it was a production website for a utility company where an error happens, and I could see the entire SQL string at the top of the web page. And I just saw that and thought, huh, now I know what your database schema looks like, and I could probably delete everybody's records if I was really in the mood to do it. So be very smart with your views and your controllers, please. Especially when you're handling very important information. Anyway, everything makes sense, I hope, here. This is a little bit more of a detailed view. If you want to go deeper into things, I'm going to kind of skip over this just to move along. But here we have a button, we have a search action, and we get to our kind of controller side and our model side. And basically, it's a very similar concept. Start with the view, send what the user wants to do to the controller. Controller talks to the model, and that comes back. We can look at this from a different perspective, and it's kind of hard to find class diagrams for MVC if you look them up, because they tend to be like larger models in a way, if you have like a real application. So what we have here is a package diagram. This is a little bit more higher level than a class diagram. We haven't talked about these yet, but basically these are your Java packages, right? Your When you set up a project, it'll ask you what the package name is. These are basically encompassing a bunch of classes. So it kind of makes sense to talk about MVC in this perspective. So here we have our model, or sorry, we have our view, we have our model down here, and we have our controller right here. In our presentation layer, or our view layer, we would have a package with a bunch of different views, for instance. So here we would have class diagrams for login view, user view, profile view. Excuse me. Basically, we're kind of collecting all these similar class diagrams together. Here would be our controller. So here's all of our class functionality for how do we route information, how do we present the appropriate views. And then down here at the data layer, this would be your model layer. You might have a model package where it's got all of the calls to talk to a database system, talk to a file system, talk to a tape drive. Whatever your data store is, you don't necessarily care, but you will have the functionalities to talk to whatever is part of your system. And again, if you look at this kind of a model, obviously it's very simplistic and all the juicy under bits are inside these packages, but there's a very clear separation of responsibilities here. And that's, again, it's the byline for this whole model. All of your data related stuff is happening in the model layer. All of your application logic or your routing logic is happening in the controller. All of your presentation stuff is in the view layer. So hopefully that makes sense. Here's a simplistic MVC class diagram, not as complicated as some of the other ones. But here we're basically just counting some information. It's very, very trivial, honestly. But here you have your view class, your controller class, and your model class. What's on the view class? Well, it's your JFrame, it's your text fields, it's your buttons, and references to the control in the model. I know we said we didn't have that, but sometimes it makes life easier to have it, as long as you hear it's privated, at least. But we have our front ends. Our controller would handle the application logic. So here we're incrementing and decrementing. In the model, we're actually performing the real operations. So we are handling our data. We're manipulating our data in here. Now I click a button, I route the action to the controller. That controller routes the intention to the model, which then updates the data and returns it. Way exceedingly unnecessary application of MVC, but it gets the idea across for something that's not a web application, right? We are separating out our concerns here. I'm going to skip MVP and I'm going to show you the demo and then we'll come back to MVP. But we're going to talk about CodeIgniter very briefly here. I've got some links as well if you want Python MVC implementations. I liked the PHP version a little bit better because it's a little more involved. So I will say this. So this is CodeIgniter. This is a PHP framework for MVC. There are lots of other ones out there. There is Cake PHP. I'm sure there are a ton for your .NET applications. If you're a Python web developer, Flask, the web server, that's basically an MVC server. If you've ever done that, it's going to feel very, very familiar here. But the one thing I wanted to say about this was I want you all to appreciate that you're seeing this working. It took me way, way too long to get this installed and running. I used to use CodeIgniter when I did like hobby/freelance web development many years ago, and it was as easy as setting up a database and plopping some PHP scripts down. Now it involves like an installer and a call to Composer to download a bunch of modules and a lot of permission configuration, and it's a big headache. So a demo that should have taken me like 10 minutes to slap together took hours, and I feel bad about it. Excuse me. So this is running on a literal web server. I'm running it on a Google Cloud instance. And if you're not familiar with Google Cloud, it is, of course, I disconnected. It's something that we have free coupons for in class if you want any of them. I just spun up an Ubuntu server in a handful of minutes. It's free to use for the duration of the class. And they even have free instances that you could run even beyond class if you wanted. But basically I'm running it as a LAMP server, meaning it's Linux, Apache for the web server, MySQL or MariaDB for the database, and then PHP for the server scripting. So effectively, it's a full-on web server that we've got going on here. Now, have we reconnected yet? Yes, good. So this is a nice little browser terminal here. I'm going to go to the web directory, and I've installed it in this code app location, which is basically their demo application. So what we see in here, actually, let me go to the web page first. So this is the web page that you see when you visit a CodeIgniter website, like by default. We have some normal HTML, we have, links, standard website, right? Well, in here, we have a whole bunch of stuff going on. And everything that we care about is an app for this demo. So what do we see? Hey, there's a folder for controllers. There's a folder for models. There's a folder for views. What's in views? Well, there is a CIS350 PHP page, a welcome message PHP page, which by default, codeapp/app/views/welcome message.php is what you are seeing here. Now, if you know anything about web development, you go to a website, and typically your default page is index.html or index.php or default.htm if you're on the Microsoft side. But here, it's all kind of convoluted in that if we go to the home page, the controller will recognize that we are going to the home page, render out this particular view. All right, so let me show you. We have to do controllers. No, sorry. Config routes. Make it a little bit prettier. So this is all very complicated PHP stuff going on. Very nicely object-oriented now. But the router, which is effectively a controller here, is saying that your default is going to be home. And I've added on here another route for CIS350. That's not going to mean anything to you now, but basically what I'm saying is that if a user goes to the home page versus the CIS350 page, render a different view. Again, there's a lot of complicated moving pieces here for something that should be simple, but it's extremely extensible and maintainable, which is kind of nice. All right, so this is my router. Now in the controllers, we see a few different PHP scripts. So there's a base controller, there's a 350 controller, and a home controller. If we look at the base controller, oh, I need to actually give it a text editor, otherwise it's not going to know what to do. Makes sense. Desert. So we have a whole lot of things here, a lot of boilerplate code for basically loading in stuff that the controller needs. I don't see anything about my view here. But what I need to do is look at home. Well, what is home doing? Home is saying, if we are routed here from the controller, render this particular view. That view is tied to that welcome message.php that I showed a while back. So if we update that, welcome message, it looks like, hey, this is normal HTML code, right? It's a bit not optimized, right? This should be in its own file for the CSS, etc., etc. But it's your normal, excuse me, it's your normal HTML code. Now what we see here, hi there 350, if I edit this page, have a lovely, wonderful, warm weekend, etc. Save it. Refresh. Hey, there's my HTML code. Pretty simple, right? But I updated a view. I didn't update the home page. I didn't update index.html. I updated a particular view. Now, where is that useful? I have this other page here where instead of going to the home page, like we've got here, I've gone to the CIS350 page. I've picked a different route. Now, a route could be handled through the URL here. I could have clicked a button to get here. Basically, I interacted with my view, which in this case is a browser. Could just as easily have been a phone application or, I don't know, some kind of internal game screen, but it doesn't matter. Basically, I am showing this view. Now, what is this view? Well, it is something that I defined as a controller where I'm going to say I need the CIS350 view if I ever get routed here. Again, this is where the overhead is coming into play. In order to add a new web page, I have to update or add at least 3 separate files. So there is overhead, but it's a lot cleaner, right? If all of you want to add your own particular term project websites here, you don't have to update the database backend. You don't have to update my view. You don't have to touch anything other than what is specific to you. Right, and then I have to sudo this because I didn't update any of the permissions on the web server. And if anybody's cringing at how often I've got to sudo everything. But this here is my my very, very trivial website, right? But it's a view. It's not a web page by itself. It's being routed through this MVC framework. All right, let me wrap things up here as well, because I don't want to do too much of this on Monday. MVC hopefully makes sense. We also have MVP, which is Model View Presenter. There's also MVVP, which is a newer one, where it's Model View View Presenter. That came out of Microsoft, I believe. But all you really need to know about MVP is that it is effectively similar to MVC, but there is a distinct lack of connection between the model and the view. So whereas in MVC, the model can actually update the view, that is completely removed from MVP. The view in MVP is effectively a dumb front end. It's called a thin front end, basically. The controller gets promoted to have more power, and it becomes a presenter. The view gets demoted and only handles rendering. Right? Whereas before, the view could have actually done some more interaction, basically has a little bit more power. The intent of MVP is to absolutely slice out the view and make it its own thing, only intended to present data. Before view had a little bit more power to it. The presenter view becomes a controller. Which one is better? Hey, I've got that over here. Which is better? That's a good question. It depends, and that's going to be the software engineering term. It depends on what you want to do. If you look online, there are going to be a lot more references for MVC. There's going to be a lot more frameworks for MVC. MVP tends to, you don't tend to see a lot of open frameworks out there for MVP. Could be because MVC's been around for a lot longer. I would say it just depends on how you want to do things. For me, I like MVC because you have that capability. MVP would be more useful if you want to swap out front ends very easily. Right, so here, if you look at this from a software engineering perspective, if I update my view, there's a chance I have to update the model. Right, there is a direct link here. Whereas here, it is completely decoupled. In theory, I could swap out one view for another without impacting the model itself. Here, there's a possibility. And I'm kind of like squinting and saying there's a possibility because you might not have this linkage with MVC. It just kind of depends. I like MVC because it's been around and I've used it quite a bit. Just depends on how you want to add your logic in there. Right? You can put logic in the view if you want in MVC. Here, you can't have any logic whatsoever. It's kind of a very black and white viewpoint for a pattern versus a little bit of flexibility. And if anybody is interested in CodeIgniter at all, it's tech. Here we go. Tech admin. Basically, there's a lovely guide to follow where rather than following the actual CodeIgniter installation guide, you have to follow a guide where you install Composer and create a CodeIgniter application from that. Other thing to mention too, so I didn't have any model going on in my little demo website here. It was all just controller and views. I didn't show you any database interactions, right? My models folder is empty. If I wanted to have a database backing this thing up, I would put my database manipulation code in the models folder. I would have a class for interacting with the database that would be called from the controller. The controller would route that data back to the view. Any questions at all from today? If we are all good, I hope you all have a wonderful weekend. Enjoy the weather while we have it. Check out the beach. It's a lovely time of year right now. We went out there last night, and it was absolutely glorious. So, you all have a great weekend. Don't think so. Might send a message about it later, though. Fair enough. Okay. Everybody, stay safe. Have a great weekend. Yeah, enjoy the sun while it's out if you can. Bye, everybody. Click. Whee! Looking at some of your projects in Unity and Godot, I'm starting to really kick myself for going all in on Pygame because some of this is really frustrating. Alrighty. You all have a great weekend. Bye, all.